Hello and welcome to everyone here today at our first Zoom meeting for the year. And I'd like to begin by acknowledging the traditional owners and custodians of the land on which we meet today. So I'm in Melbourne, so the peoples of the Kulin Nation. I also pay my respect to their elders past and present. Thank you very much, everyone, for joining us today. It's lovely to see you all. We've decided to have it in a Zoom format so that you can actually see who the guests are, and please feel free to introduce yourselves in the comments section. Thank you for keeping yourselves on mute as far as possible. And with that, I probably should have introduced myself. I'm Nikki Rousseau, the CEO of Robotics Australia Group. Sorry, I should have done that initially. I'm assuming everyone just knows who I am. So I've just recently been appointed to the role, having had a robotics company myself called Exaptech for the last 8 years. A little bit of backstory, I got appointed to the board, and it soon became apparent that they needed an operational person, and I was stepping out of Exaptech. The company's in sleeper mode. I'm not importing any more hardware. So I hope that's a sufficient backstory as to how I became the CEO of Robotics Australia Group. It's my mission to meet you all. Please feel free to contact me after the Zoom meeting as well if you have any questions. But with that, I think I'm going to hand over to Sue to get us started for today's session. Thanks, Sue.
Thank you, Nikki, and thank you also for taking on the role of CEO. I think that because of your efforts, we're able to accelerate a lot of our ambitions much more quickly than we have been able to do in the past. So really looking forward to working with you and seeing how we can really help to build a sustainable robotics industry here in Australia. Well, thank you everyone for joining. And as you know, that we decided the topic was going to be on underwater robots, but then because they're clearly very important to Australia, given that between us and our Pacific neighbours, we're responsible for 20% of the world's oceans. But I think after we advertised it, we realised that was probably a misnomer. We really just mean marine robots. So they don't necessarily have to be underwater. They can also operate on the surface as well. And they can be put to a number of different uses. And that's what we're hoping to explore with our panel today. So our panel is made up of people who are working in this marine robotics space. We have Ken Chadda, the CEO and founder of YellowFin Robotics, Ruth Patterson from Entire Oceans, who has done a lot of work reviewing the different types of robots that operate in marine environments, Professor Stefan Williams from the University of Sydney, who has been involved in some long-term monitoring of the oceans surrounding Australia, and Adam Chadda, the CEO and founder of MetaSpacial Solutions. So welcome to our panellists, and I think I'll go to you first, Ken. I'm hoping that each of our panel can just give us a quick introduction and tell us what underwater or marine robots mean to you and where you see the opportunities lying in this space. Ken. Ken, you're on mute.
Can you hear me now? Yeah, okay. Gee, I lost 30 seconds. Sorry. Okay. CEO and founder of YellowFin Robotics based in Melbourne. We've been around since the last 7 years, still kicking and alive. Briefly, I've been a sailor since I was 18, and I did that for 25 years and retired as a ship captain. Both I've done my fair sea time on the deepwater ships and also the oil and gas sector in Australia and Asia Pacific. So I've seen firsthand where we are still dumb as far as work and safety is concerned, and where robotics can actually make a huge difference. Where I think the opportunities lie in water and subsurface robots is what takes us to water: leisure, work, and warfare. They're the three categories I would say we've got big scope. Thanks.
It's going to be the is going to be the theme of this, that we all forget to go off mute. So I was going to pass over to you, Ruth, just to find out, a bit more about you and where you see the opportunities in marine robotics.
Thanks, Sue. So I'm a physical oceanographer based up in Darwin in the Northern Territory. And I guess I've had 16 years in the oceanographic industry working up here. And Darwin's, it's a really remote place with very few people. And so for me, it would be good to get more kind of robotics capabilities up here, basically for monitoring and surveillance for multiple like different uses. And sorry, a little bit about my background is, so I'm running Interior Oceans, and we have contracts anywhere between monitoring assessing the impact of climate change on turtle hatchlings, all the way through to I'm on the Navy Advanced Capabilities team as part of a company called Elysium, out of Elysium EPL, that runs out of Canberra. And so that's sort of where my expertise lie. And definitely in ocean observing is where I think marine robotics is going for myself.
Thank you, Ruth. And Stefan, welcome. And would you mind letting everyone know a bit about your background and also where you see the opportunities in marine robotics?
Yeah, thanks, Sue. So I'm Stefan Williams. I'm a professor of marine robotics at the University of Sydney, based at the Australian Centre for Field Robotics. I've been working in robotics in the oceans for 25 years and really been thinking both about the fundamentals in developing algorithms and things, but also in platforms and really how we use these robotic platforms to better understand the ocean. So we've led a long-term monitoring program deploying autonomous underwater vehicles at sites around Australia, looking at the impacts of changing climate and oceanographic conditions on sensitive reef habitats, doing that on an annual basis and really delivering data for ecologists. We've done work in underwater archaeology and deep sea geoscience, really deploying new sensors to help understand these oceanographic environments. A big focus on optical imaging, building detailed three-dimensional models of those environments. And a lot of the work that my students have been doing is really on downstream. How do you take that data that the robotic systems are collecting and turn it into insights and information that can inform policy and economic opportunities. I think the big opportunities, and we see, some commercial potential here in offering data as a service. So being able to get robotic systems out, supporting areas like offshore energy, so offshore wind, oil and gas, defense applications, ecological monitoring. So I think there's a huge range of opportunities in this space.
Thanks, Stefan. And now I'll hand over to Adam to do a quick introduction and to tell us where you see the opportunities.
Yeah, thanks, Sue. So my name is Adam, CEO and founder of MetaSpacial Solutions in Melbourne, here in Australia. So we've been in a geospatial industry for over 20 years, and our focus mainly on designing and building capture systems, specifically using vision-based custom cameras that we design for capturing data from land, water, and air. So water applies for underwater applications. We have a couple of clients who use our technologies for capturing data on autonomous robots and boats, for offshore applications. So where I see this has a big opportunity in future, we can implement and work with the other groups in designing a visual 3D sensors that could be implemented on the underwater robots. And also another aspect which is more critical is the navigation aspects, because when you have a robot, so how are you going to navigate, how are we going to know that where it is precisely underwater? That we believe that we do have some solutions that we can work and integrate and offer to the industry. Thank you.
Thanks, Adam. So now I'm going to, just put out a question for all of you to have a say on, if you choose to. So the first question is, the market for underwater or marine robots is pretty diverse, as you've just outlined in terms of the different types of opportunities that are available in the space. So what are going to be those opportunities in the future? We've covered off on defence, environment, looking at climate change, but, are we going to see an expansion in the market? What is that going to look like, and who's going to be leading the way? Ken, I might start off with you again.
Okay, I'll start off by unmuting, so that's a good start. Okay, I'll be just dealing with the marine side, so where I've got the best visibility at the moment. We've got life-saving in New South Wales, where Westpac helicopters have deployed drones, watching out for sharks and for personal safety in the water. And the shark nets have been in the news and been a bone of contention for years and years, and some community believes in it, some hate it. So how to cut across this red tape and still ensure safety for personal, going to water for leisure is, we need to deploy drones on surface or subsea, which can look out for the shark. And it's not only detection of sharks and other, I would say, sea life which can come in harm's way, and also there has to be a deterrence. So there is an opportunity for, I would say, a humane type of deterrence factor. Could be an acoustic pulse or an electric pulse, which can determine wildlife like that. Another area of opportunity, very different to what we've been discussing so far, is Australia depends. Our GDP is run, I would say, by WA, and WA runs on what? Mining. Mining means shipping. Shipping is export. So where can underwater robotics help in ensuring commercial viability and maintenance, is maintaining those shipping channels? We, till date, I've seen firsthand, when you need some work to be done in the shipping area, in the shipping, maritime transport and logistics area, we are going across, shopping around the world. If you're looking for a dredger, some dredger has to come all the way from Netherlands and come and dredge our waters over here, and similar cases in other maritime aspects. So there is a clear-cut industry with the advent of offshore wind farms coming up in Australia, with Victoria being the first, New South Wales being the second, South Australia is going to be the next. So there is a business case where subsurface and seabed structures need to be worked with. It's not only monitoring and mapping and sensing them. They need actual physical work to be done there. And that's where I see, the flesh and bones robotics, underwater robotics is going to help. We will need robots which will need to ensure channels are clear, channels are dredged to a certain depth, and they can monitor them on a regular basis. We need robots underwater who can assist wind farms being drilled into the seabed, and so on and so forth. And talking about the third opportunity arm, I would say, is warfare. We are looking at nuclear subs. Yes, they are coming. They will create small number of jobs there. 8,500 is direct jobs, and in the next few years they say about 15 to 20,000, but that's not what we should be looking at. So our main focus should be, what's the alternative? Getting a handful of nuclear subs is not the end and be all. We have companies in Victoria who are flying below the radar, but they are doing phenomenal work in the defense sector, where they are developing micro drones, which are going to be part of a soldier's armory. They live on a soldier's body and can be launched on their will and requirement. So we need similar micro sub arm, I would say, section within our Navy. And that's a very how can I say, in scale and in criticality where we sit as Australia in the geopolitical scene today is not going for the nuclear subs in a big way, but developing our own ability and capability in micro subs, which can do a similar, if not better job.
So, Kenny, thinking something like the Ghost Bat, but underwater?
That's correct. Something on similar lines. So a sub doesn't need to be, I mean, many people on the panel probably will know better, and size and sound is the biggest enemy for any sub. This can be countered by reducing both. And how do you do that is going micro. They can pack a punch as far as destruction power is concerned. We're talking very similar to kamikaze drones. So you're looking at kamikaze subs, micro subs, which can be used when they need to be used for a certain. Of course, I mean there are always controls around that, but that's a very clear opportunity as far as defense is concerned.
Okay, thanks, Ken. Ruth, what do you see? How do you see things evolving in the future?
I'm very much in the scientific space of ocean observing, and I think marine robotics, particularly the surface craft, have really big potential to be filling both disciplinary and geographic gaps. And I think this is really important in Australia because our northern waters and many of our southern and peripheral waters are pretty unknown, and the water column itself and the weather, it's pretty difficult to predict on smaller scales than what we already predict in terms of weather and conditions. And so when you think about it, everybody on this earth uses weather predictions, and if we want to improve those for navigation and planning and risk assessment and climate assessments, we need to understand data to a more detailed scale. And so we need to access places where the global ocean observing system can't quite reach. And robotics, particularly surface vessels, have the potential to be able to navigate, unlike most of the other GOOS or global ocean observing systems platforms. So, and they also have quite large payloads, which is different to the other platforms. And I just see it, I see the robotics as being a part of this network, and we haven't quite got there yet. But for me, I think that's where the opportunities lie. And of course, who wants the weather? Everybody, every government, every person and industry. So I think that's where one of the large sort of opportunities lies. Thanks.
Thanks, Ruth. And Nicola Clote has just put in the chat that there is actually a marine equivalent of the Ghost Bat called the Ghost Shark that Navy is working on. Thanks, Nicola. Sorry, for people who don't understand the reference to Ghost Bat and Ghost Shark, they are autonomous vehicles that are actually paired with crewed vessels or machines to to act as a I think that the term for Ghost Bat was loyal wingman originally. So the idea is that they would work in concert with crewed vessels or machines. So I'll pass over to you, Adam, to get a sense of where you think the future is heading.
Yeah, as a geospatialist, we mainly focus on digital twin and a replica of the real environment. So we can, if you have a real representation of what's happening underwater by utilizing these robots, and of course the smarts and the sensors on the robots. So if you know where we are precisely underwater, that's a big challenge by itself, because we might not have satellite receptions. There are some other technologies already help with the navigations. there are technologies in the solution, the opportunities and feature for topographic mapping and the asset inspections. There are lots of assets underground, under the water, sorry, that require to be inspected regularly, and then the robots can be the very good and suitable solution and technology, providing that the precise sensors and navigation systems are deployed and used on these robots for the capturing the digital twins and processing, and also comparing these together for environmental monitoring. So if we have any changes underwater that's not necessarily visible, but they're happening, they keep happening. So if we have a regular monitoring systems that can monitor in 3D, capture these, and we can monitor these in a data management systems over time and detect changes. So these also all provide what's happening in the environments that's not necessarily visible environments, but invisible environments.
Thanks, Adam. And look, I'm curious what you think about how the space is evolving in terms of underwater sensors, because obviously with sensors for ground robotics, we're seeing a continual decrease in price, increase in capability, new sensors coming along quite regularly. How is that impacting in the marine environment?
With the sensors, there are various types of sensors. So we mainly focus on the optical sensors because that's what we can see through. There are a bit countable limitations if you just wanted to compare these with the sensor that we can use in a normal atmosphere. That we don't have any limitation in terms of the visibility and the light. So the underwater, so we normally use a customized spectrum, so mainly in a blue spectrum, because that can penetrate water. But even as we go deeper, up to 40 to 45 meters, even the blue spectrum is absorbed, and we can't really see through. So then there are lots of other techniques, like introducing custom light source with these visual sensors. We wanted to see through. So of course these kind of add to the cost of the sensor and technology, and they're not as cheap as they're not a consumer grade solution. They're specialized in the niche markets. Technologies that needs to be developed and integrated. I don't think we're gonna have anything affordable or anything low cost for the underwater imaging systems. They're going to be even more expensive, especially with introducing the navigation systems and the new modern technologies to see through. So it's gonna be even more expensive.
Yeah. Okay. Thank you, Stefan.
Yeah, I think similar to Adam, I think we've had a big focus over the years on optical imaging, and one of the requirements of that is having vehicles that can operate in close proximity to the seafloor. So the ability to navigate around and over complex subsea environments, I think, is a big requirement in order to get high quality optical imaging. Having all the navigation systems, the logistics in place to be able to deploy and recover those vehicles safely is a big thing. And I think we've spent 15 years really refining processes around that, as well as the platforms themselves, and thinking about the way that we deploy these sorts of vehicles. The sensing, the lighting, all of those things are important. I think traditionally there's been a much bigger focus on acoustics, so using sonar systems, and that continues to be important in a variety of applications, including in defense. But I think there's the ability to have close inspection using optical systems, being able to deal with the volumes of data that we're collecting with those platforms and making that available to the end users that we work with. We put a lot of effort into workflows that allow people to work with and access the data, all georeferenced. So, big opportunities there, I think, in having those sorts of workflows and information available to end users. And currently, we've got big projects in the defense space, looking at surveying littoral environments. So, being able to look at mine countermeasures and things like that is a big opportunity, I think. I mentioned before, I think offshore offshore resources. There's a lot of developments are going to be coming down the pipes, and I think having sovereign capability to be able to do the surveying, to collect the information that's required for regulatory and permitting, and really understanding what the impacts of some of these new developments are going to be, I think there's a big opportunity there. We've also had quite a bit of interest in the capacity to build vehicles that are designed for particular applications. So bespoke vehicle design, so taking sort of the core technologies and being able to reconfigure that into different capabilities has been something that we've had quite a lot of interest from the community. So I think being able to build vehicles with sensing payloads that are tailored for a particular application, understanding how to deploy and recover those systems, having the control planning, all that infrastructure in place, I think is something that's come a long way in the last 10, 15 years. And I think there are some pretty significant commercial opportunities in this space, as well as supporting the more scientific, exploration and investigation that Ruth was talking about. I think there's sort of complementarity in the sorts of things that we can do, these sorts of platforms.
Thanks, Stefan. So, yeah, it seems like a lot of the opportunity is that there's still so much that is unknown and so much ground yet to cover. Sorry, just to give everyone in the audience a bit of an overview, Nikki has mentioned if you have any questions, please put them in the chat. The format is that I'll go through a couple of questions with the panel, and then about 12:45 we'll go through and have a look at some of the questions that are coming out in the chat. So bear with us. We have sort of touched on this, so I'd like the panel to comment on, the technical challenges that are still to be overcome with this deployment of marine robots. So I might mix it up. Maybe, Stefan, we can start with you this time.
Sorry, I'm muted. Are you asking about partnerships or what?
Oh, sorry. I said, what are the technical challenges that we still need to overcome?
Yeah. I think we've overcome a lot of technical challenges. I think one of the big challenges is, putting electronics in a saltwater medium is really, those things are not designed to go together particularly. But, we can design systems and sensors that are able to be deployed reliably in those kinds of environments. I think understanding the physics of the medium and designing for optical systems in particular, having the right configuration of cameras and lighting and et cetera to get very high quality imagery is something that I think we've come a long way in and are able to reliably deliver very high resolution georeferenced imagery. So that's I think we've come a long way in that. The technology is still relatively expensive, so it's relatively low volumes typically of the main navigation sensors and things that are on board these vehicles. So, we've seen sort of the advent of drones, that are relatively cheap. Underwater, it's still a bit of a challenge to make cheap underwater vehicles that are able to to be reliably navigated and operated over long periods of time. But I think there are new innovations coming along in that space. The downstream, so advances in AI and machine learning are really allowing us to make sense of the data that these vehicles are collecting. So I think there's some challenges there. And somewhat facetiously, I think one of the key challenges, I guess, is that the number of deployments is equal to the number of recoveries. So actually getting the gear back, having the safety systems in place so that if something does go wrong, you're able to recover the equipment. I think there's an art in ensuring or maximizing the likelihood of being able to recover equipment at the end of some of these campaigns.
Thanks, Stefan. Ruth.
Hi, sure. So technical challenges from my perspective are really, I just see a lot more work going into developing the actual robotics and potentially less work or less sort of maybe interest in the peripheral services. And Stefan and Adam both touched on those. Seeing the data go from the actual platform to a usable, to being used. And that could mean many, many different flow states and different types of applications and analytics that might end up, for different groups. So, for example, if you're doing navigation and control of the actual USV, you need semi-real-time data. And so getting those instruments and the platforms connected, and then having a quality assurance sort of data product coming through almost instantaneously, you start to get into this Internet of Things world. And that's what digital twins, real digital twins that are instantaneous sort of reflections of reality, that's what that's gonna need. And in the underwater world, that's a huge challenge. So, and then Stefan also said that the AI and ML it's going to be a massive part of having those data. And I'm talking environmental data, but it could be any type of data processed and delivered very quickly. And it could be from any application, such as navigation to sort of intelligence, to geospatial intelligence, defense surveillance. Any of those things are going to require the data to be proofed, quality assured, and processed in some way very quickly. And so for me, I haven't seen too many examples of that. And I think also connecting the groups who can do that really well with the actual robotics industry is a challenge, because many of the robotics groups that are developing the actual robots are startups, and they don't have the sort of funding to compete with, I'll say compete with defence. They're probably mostly working with defence, but to be able to sort of grab the peripheral services to enable the technology to sort of perform up to its expected performance. Yeah, so
that's a very good point. Thanks, Ruth. And Nicola has mentioned in the chat, about what you've just touched on, Ruth, about underwater comms. If some of the panelists might like to comment on that, but I'll pass over to Ken. What do you see as the technical challenges, and do you have any views on underwater communications?
I can actually copy and paste what Ruth just said. She just hit the nail on the head there. Absolutely. I've been in touch, and we talked to other startups too. One of the superstars of this industry is Tom Loeffler from Halbot, and he's doing some very good work in looking after the environment and also filling in the industry gap. So the common spine of the problem lies in connectivity. How do you ensure connectivity subsurface, and also ensure transfer of that data, as Ruth mentioned, in almost like real time sense. So that is the biggest concern. And you have pockets where you have, phenomenal speed of up and downloads, but you will come to places within a CBD area where it's, we're talking marina environment. You go to any marina, you cannot be assured that you're going to have a similar kind of connectivity of data in those spots. That is one big black hole, I would say, for startups like us to make a startup or a prototype into a commercial viable product. So because the end client, people with the big pockets want to see, they don't care how many hours, what take, and what sort of research you're doing. They want to see the end result. And the end result is, fortunately or unfortunately, dependent on this connectivity. Another big thing is the tether system. Now, when running robots subsurface, most of them, if not all of them, are tethered at the moment. So much so in the oil and gas, we do, well inspections, wellhead inspections for offshore installations. So you send ROVs down from the back of a platform or a ship. All are tethered. That's for air, for power. So how do we get across ensuring, if you have to send a robo, regardless of it's not limited by the depth you can send it to, but also ensure, as Stefan mentioned, you need to retrieve those assets also. How to ensure you have enough power, enough reserve power, enough performance using that power on the robo itself to, make it into a reliable product. So I would say, yeah, connectivity, power.
Thank you, Ken. Adam.
Yeah, I would touch on precise navigation again, because these costly sensors and robots, when they're utilized to capture data underwater, so if it doesn't know precisely where it is, let's say because of the limited field of view of the lighting and the sensors, it would capture one or two shots or a few images, but if they're not properly captured with respect to each other, we can't put them together and create a real digital twin or a real model. And we become aware of that once it's not underwater, it's post-processed, and we see that it needs to go back again because we missed an area. So that's very challenging issue to kind of address. And because underwater, there is no such precise GPS or satellite signals receptions. Unlike RTK or PPK solutions, we can use satellites. So there are a few limited technologies like acoustic, solutions, or the image-based navigations like visual stamps, or new technologies like optical gyros or north-seeking gyros that could be utilized and integrated to offer these robots a precise self-navigation, so they would know where they are, where to go next to cover the area without any gap in data capture. So I guess that's very crucial to have, and it's very challenging to consider this.
Great. Okay, thanks, Adam. So in terms of, Ruth, you've touched on this, I wanted to find out your views on the capability gaps in the Australian robotics industry that you would like filled. And, Ruth, you've made a very good point that with a lot of our startups, because of their size, then, they are limited in terms of being able to make sure that they can supply all the peripheral services, which potentially they could do if it was possible to link them up with the people that were able to provide those services. So, is that lack of coordination and collaboration one of the biggest gaps, or can you also see some other gaps, Ruth?
I think that is definitely a gap. I'm not sure if it's one of the biggest ones. It depends on where you're standing. I think the robotics industry in Australia is quite small. That could be a plus or minus. I mean, it's a tight-knit community. I think probably most industries and groups could do potentially a better job of collaborating. And I think that's really needed if you want to sort of, because there's no one sort of group or industry that can do it all. And so, collaboration is the new competition. So one of the capability gaps I really see is the upcoming generation of younger people entering into robotics. And what I'm seeing is a lot of mechatronics engineers and those type of people, and obviously they're essential to building the robots, but there's a smaller emphasis on people who can apply the learning and their actual use cases of the robotics themselves. So there are fewer people who can connect the dots between startups who manufacture underwater or marine robotics with the end users. And I think that's got to do, in particular in the marine environment, that's got to do with our marine undergraduate degrees being focused on marine biology and not so much on oceanography. So I'm not sure if you can do an oceanography degree as an undergraduate in Australia. Probably through the defence you probably could, but as a civilian, I think they're quite small groups operating out of the marine sort of dominated universities that focus on physical oceanography. So I'd like to see more operators and people who are who have the vision to see how the robotics can be used and then integrate that into everyday sort of things that are happening and disrupt the community. But I also feel there isn't a lot of support or in higher sort of fathoms. And I think we've seen in Australia many really successful robotics companies go offshore because potentially the support isn't there by the community or the government or who I'm not sure. Perhaps one of the other panelists can give me some more, some insight into that. But I think there are some successful Australian marine robotics companies that have gone offshore, and potentially the US has served them better. So I'd be interested to hear what the others think of that. So, yeah.
Thanks, Ruth. And, I think that lack of link between domain knowledge and mechatronics, I think it's not peculiar to marine robotics, but as you say, it's a double whammy if people can't even get the domain knowledge by studying oceanography. So thanks for that perspective. So Adam, what do you think are some of the capability gaps?
Actually, probably I'm not a real expert in the industry. So I'm considering myself as a subject matter expert in the sensors and navigations and the geospatial aspects. So probably this can be best answered by the other panel members.
Okay, thanks, Adam. Stefan, what are you seeing?
I guess picking up on what Ruth mentioned, I think having people with that kind of cross-domain knowledge is challenging, and I think it's also in when you're competing with some of these mechatronics students who have maybe a background in machine learning and AI and things, you're competing with a very hot market in terms of employment opportunities. Although we have seen some significant layoffs over the last couple of months or a couple of years, I guess. So maybe that'll balance out a little bit, but kind of the salaries and things that people can command, particularly in that sort of software area, it's hard for startups to compete, I think, to offer people an opportunity that would be sort of comparable with some of the big commercial opportunities that they might come across. Having said that, you do get, people who are really passionate about taking technological innovation and understanding and applying it to solving particular real world problems. And I think the maritime's an area where you do get a lot of passionate people. And I'd say one of the biggest successes in terms of robotic platform deployment has been the Argo Float program that came out of UCSD, which is focused on collecting physical oceanography data using robotic platforms that, $15,000 a piece. They are designed not to be recovered. So my adage about, making sure you have the same number of deployments recoveries, if you're willing to make something that's cheap enough that can collect the data that you want, and deploy them. I think in this case, they've got over 4,000 of these things floating around the oceans, taking measurements of and adding data to ocean circulation models. That's revolutionized the way that people do physical oceanography. And I think if we can think about analogous innovations that don't require expensive ship time, and we can use innovations in robotics, whether it's surface vessels or long range autonomous underwater vehicle platforms, to collect data that, would cost a lot of money to collect with the ship. I think could have a big impact. And so I think there are big opportunities for people who are coming into this field. Getting the cross-domain training, I don't know that I can't think of any specific marine robotics programs, at least in Australia. I know University of Rhode Island has some. There's a few places around the world that do, but in Australia, that's not. You've got your common undergraduate degree, and then some bespoke master's programs. But most people get their training in this sort of area through PhD programs, and we've always had good success in attracting students to join the work that we're doing in marine robotics and to work towards PhD. And some of the companies that have been mentioned have come out of PhD students who've gone on to see an opportunity and to sort of stand that up and are having big impact.
Thanks, Stefan. And I'll just hand over to you, Ken, see what capability gaps you are concerned about.
Yeah, I will talk about from an entrepreneur's and a startup point of view. Startups, it's very tough to compete. I would say there is a lot of lip service in Australia, but not enough fiscal support for startups and companies who want to make a mark in this industry in Australia. Ruth mentioned it. I mean, there is a better business case for a company like me to wrap up everything in Australia, set up shop in Abu Dhabi. There are so many incentives, and the market size it throws open with Europe at your doorstep is much better. But again, call it maybe a defective gene in me. I'm a big sucker for Australian manufacturing and supporting Australian businesses. So that's my personal downfall, as well as to say. There are programs. I mean, Breakthrough Victoria came up with a big bang a couple of years ago, $2.2 billion in the budget. Now, these sort of programs look very good on paper, but they are looking for the next unicorn. How many unicorns you can generate out of one state? Again, as Ruth mentioned, as Stefan also mentioned, we need to support ancillary industries connected to robotics. For me, if I want to manufacture and produce, let's say, a dozen wash drones tomorrow, I have to source 90% of my parts from China. Why is that the case? If you want to develop that industry in Australia, why don't we have those manufacturing capabilities so I can go drive 200 kilometers if I have to, but I can source the part? All of this ramps up, and this has got a domino effect on the quality and the time of service that companies like us can deliver in Australia. So this is one area which has no focus whatsoever, I would say, purely from a business point of view. And engineers, again, I mean, we have engineers being churned out, a lot of mechatronic engineers coming out. What I've seen firsthand, it's like a jack of all trades, master of none. We would definitely like to see mechatronic engineers with specialization in certain field. I mean, there is a dearth. I mean, I cannot find any electronic engineer who has got some basic handle on mechatronics, but specializing in electronics, very hard to find. And if you do find someone who's qualified, as far as your qualification is concerned, educational qualification, but has no work experience. So I know that will come with time, but at the moment, I think we are just concerned about churning out X number of mechatronic engineers, but to what use?
Okay, thank you. And I realize we're running short on time to actually go through some of the questions that have come up. One of the questions that came up a bit earlier was around whether these robots are exploring shallower waters. Are there any that hover in waves closer to shores, or are they usually only in deeper waters? Anyone would like to jump in to answer that one? Ken?
Yeah, I would say we need to start with shallower waters, especially what I spoke about. Dredging robos are going to be in shipping channels. So you're looking at, I mean, very close to our doorstep is your Star of the South. It's up and coming. You're going to have, at least 30 years of work over there. We need robotic support for those structures. Mind you, they're going to take 8 to 10 years to install that farm and another 25 years of work life. So all of the structure which is subsea will need monitoring and maintenance. So let's start from there. Deeper water, there are a lot of other complexities. I mean, the biggest one is going to be your power and connectivity again. So yeah, test case and test bed should be shallower waters, in my opinion.
Okay. Well, I'm sorry, I did run a bit short on time to go to the questions. So I'm going to get everyone to wrap up with a, very quick 1-minute key takeaway or top tip for the audience. But also keep in mind that some of the questions in the audience were, are skills from robotics in other domains transferable to underwater? And also if the panel has any advice on deciding on a specialization in robotics. So if you can, give us your top tip and maybe tackle one of those, that would be fantastic. And Stefan, I think I'll start with you.
I think, training in robotics is pretty applicable to different domains. I think there are some issues specific to underwater, but I employ, people with a mechatronics degree without a huge amount of experience, specific underwater experience necessarily, and I can train them up, and they become effective pretty quickly. I think fundamental skills in electronics, I think it was Ken was alluding to, is something that we look for, and I think having a good mix of staff with skills in mechanical design, electronics, and more of the downstream, the software, the algorithms, the control, planning, data analytics. I think you need a pretty well-rounded team to be effective and to operate in this sort of space.
Stefan, if you get a chance, you might be able to answer one of the questions in the chat, just by typing an answer in there, if you have any views on that, because I'll quickly go around to our other panelists. Ruth, top tip or takeaway?
My hot tip for everyone in the robotics industry, including students and startups, is to be collaborative. I think there's massive opportunities in collaboration in this space because it is a small community, and I think when it comes down to it, there's actually quite little competition because it is a small community and everybody around Australia has their own little niche. And I think even if what you're doing is quite similar to someone else, there's going to be facets where you guys can hold each other's hands and help sort of promote each other. So that's my major one. For the, there's a question here, how do you find weather temperature influences tech challenges? I know there's the AIMS sort of testing range which is really, I think, really amazing and important. But Stefan's got onto that. But in the top end here, we've got 8-meter tides and turbidity. Like the water is like chocolate milk during moving tides, running tides, and that's a huge challenge. So you've got condensation, humidity. So things that we would normally do up here, you wouldn't do in the southern states. So so employ a local. I think it's a big take home for weather challenges. If you're looking down to Antarctica, employ someone from Hobart. There's heaps of people down there. And if you're looking to do something in the tropics, employ someone from Darwin, like me.
Thanks, Ruth. Okay, we're just a very quick hot tip from Adam and then Ken.
I guess focusing on Australia, I guess really good to keep these networking between different specialists. I guess to me, I had the chance to get to know other panelists in here, Stefan, to understand here, and then I guess already I started thinking how we can take this to the next step. This is really a first move that is without having these sort of forums or communications discussions, nothing would happen. And I guess Ken also touched on manufacturing and why we can't do things in Australia. So the good news is we can, but we don't know what we don't know. And so until we discuss and understand that what capabilities is available in here. So I guess it's very important to keep this networking and as Ruth mentioned, the collaborative culture in any industry, not just in robotics. That will, because I can say, in Australia, we've got lots of, skill sets and lots of experts and talented people that we just really need to, just to discover them and then, and I that got the capabilities to, to make the most stunning technologies here in Australia.
Thanks, Adam. And we'll finish off with you, Ken, and then we're almost at time and I'll hand back to Nikki.
Well, thanks. First of all, it was my privilege to, listen to all the other panelists. Thanks for your knowledge imparted. What I would like to say is, yes, I've been whinging, as an entrepreneur and whatnot, but don't take it in the wrong way. I would say all the people who are listening also is, this is a fantastic country. What is frustrating is robotics is under-realized in this country. We are the country, one of us designed the submarine which took James Cameron down to Mariana Trench. So we have got the brains. All we need is the support for the industry and the entrepreneurs and the startups who have got the brains and the will to do it. We need a structured approach. It needs to come from the top. It's just not throwing money just for the sake of it. Support industry, support startups, support ancillaries, so we can do it in a proper way. And I truly believe, Nikki and Stu, you guys can do it under Robotics Australia group. This sort of, visibility to many other people may go a very, very long way in plugging those holes.
Thanks very much, Ken. Now I'm handing back to you, Nikki, at time to wrap up. Thank you, all of our panelists, and thank you to our audience.
Thank you very much to Sue. If you don't know, Sue is the chairperson of Robotics Australia Group, and I report directly to Sue, so I'll be on my best behavior going forward here. But to our panelists, thank you so much for your time today. I appreciate it very much. Just to our audience, I actually have a podcast, Let's Talk Robotics, and Ken has already been a guest, but Stefan, Ruth, and Adam, you will be shortly hit up to be guests on my podcast as well. And now you've met me, you can't say no. So look out for the email coming your way. Just a little bit on Robotics Australia Group. We are the peak body for representing robotics in Australia. We connect, advocate, inform, and promote on behalf and for robotics. And that is our mission, is to get the industry stronger, to collaborate. That's a word that's been mentioned here today a lot. And that certainly is our focus. So have a look at our website. We are looking for members in whatever way. So I've noticed here some questions on what field to be going into from Carmen. I've told her to hit me up because we do have some people that can assist her in that way. And the invitation is out to all of you. If you need any help with anything, please reach out. The board and myself are extraordinarily connected people in the field, and what Sue and Dr. Nathan Kirchner don't know about robotics in Australia, I suggest is probably not worth knowing about. So they really do know everything. Sue was also responsible for the 2018 and the 2020/22 Robotics Australia roadmap. If you're not aware of that, again, go to our website, hit us up, we can send you the documents, and that's really what's going on in our industry. Just to wrap it up, the National Robotics Strategy, Sue is also representing the robotics community on that panel, and we're waiting. It's in a draft mode at the moment, and we're hoping towards the end of the year we'll have some sort of strategy that's released there. again, follow us on LinkedIn for the latest news and updates, and that's where you'll find it. So with that, I'm going to wrap up. This recording will be available on our YouTube channel in the next week or so. To our panelists, Adam, Ruth, Sue, thank you for your time. Stefan, thank you so much. And Ken, thank you. And I hope you all have a wonderful day, and see you again in August for our next one. And also, just lastly, if you're in Melbourne, we have a meetup group next week. Please check out Eventbrite. We're actually putting on some refreshments, so please join us. Stefan, you can fly in from Sydney because I know you don't want to miss that. And Ruth, you as well. Adam and Ken, I expect to see you there. So thank you and have a good day.